Hello everyone. Let us see now. Next point, that is first we have studied now the how to calculate the inverse Laplace transform using partial fraction. Now we are going to see how to calculate inverse Laplace transform by using the next point, that is convolution theorem. Okay. Let us see the statements first. Let L inverse of phi 1, yes, that is there is a one function like fx, gx, f of t. It's like that only. F of phi 1 of s means one function which is in s variable. Suppose L inverse of this phi 1 s is equal to f1 t. Whatever the inverse of this function, call it as f1, first function, f of t obviously. And second, there are two functions phi 2s also, and inverse of that phi 2s is f2, suppose f2t. Okay, these are two functions whose inverses are f1t and f2t. If you know this, then inverse of their product phi 1 into phi 2 can be calculated by using this convolution theorem. What is the formula for that? L inverse of phi 1 into phi 2 is equal to, it is a basic integration 0 to t f1 u f2 t minus u. Okay, what is this f1 u and f2 t minus u variables means this whole integration is integration with respect to this. Okay, this integration is with respect to u. Integrations limits are 0 to t, integration is with respect to u. Whatever integrand in this integration is, we have to take the integration with respect to u only. Okay, except the u, even t also constant with respect to this integration. Okay, understand this difference. Suppose f1t and f2t, these are the inverse Laplace transform of two functions. Then inverse Laplace transform of their product can be calculated by this convolution theorem, whose statement is L inverse of phi 1 into phi 2 is integration 0 to t f1u. What do you mean by f1u? Here we have already f1t. Just replace t by u in this function. Okay, and what is f2t minus u? This is f2t. Just replace t is equal to t minus u everywhere here in this answer. You get f2t minus u, and put this product in this integration. Solve this integration. This is very easy integrations. Generally, u into v rule. Okay, and du with respect to u, we have to solve this integration. That is the answer for this inverse of product of two functions. Okay, now here there are some rules or notes. First, this is u into v rule. What is u into v rule? Just u into v1. Suffix means integration, dash means derivative. U into first integration of v minus alternative plus minus sign. U dash means derivative. You have to take derivative of u here. U dash, u double dash, u triple dash, and so on. And taking integrations of v, that is v1 first integration, v2 means second integration of second v, and v3, v4, and so on. Okay, alternating plus minus sign. This is u into v rule. Okay, and these are the already we have seen all these formulas. Okay, we are just recalling that 2 sin a cos b, 2 cos a cos b, and 2 sin a sin b. These are the three formulas we have already used in first chapter also. In this point also we are using this. Okay, and this is the new integration formula. Sine hyperbolic, generally integration of sine is minus cos. Okay, and integration of cos is plus sine. For normal angles there is a matter of plus minus sign, but whenever hyperbolic function is there, here sine hyperbolic function, cos hyperbolic, there is no any matter of minus sign here. That means integration of sine hyperbolic is cos hyperbolic, integration of cos hyperbolic is sine hyperbolic. There is no any plus minus sign here. Okay, remember this formula. Okay, now let us see the example depend on this convolution theorem. First question is find inverse Laplace transform using convolution theorem. If there these are very easy examples. Okay, these examples can be solved by earlier method also, that is partial fraction methods, and some of the partial fraction methods can also solve by this convolution theorem. Okay, if in the example itself, if they are not asking anything, just the question is like that, find L inverse Laplace transform. You can use either either partial fraction or convolution theorem, whichever you feel it is easy, you can use that. Okay, but if they are asked particular for a convolution theorem or partial fraction method, you have to use only those methods. Okay, here we are now studying the convolution theorem. The first example is we have to find out L inverse of this function. Okay, now what is our first step? This statement. Okay, whatever the inverse we have to find, uh, just split this function into two functions. Call it first as phi 1, call it a second as phi 2. Whatever you there is no any rule for which function we have to call first and which function we have to call phi 2. There is no any rule. You can either, as per your convenience, you can call it at any way. Okay, the answers are same. Okay, then first step is you have to split this function. What is the function here? 1 upon s into s square minus a square. If you observe this, there are two functions. First is 1 upon s and second is 1 upon s, a square minus a square. Okay, then okay, see, first split these functions into two such functions. For that we can easily calculate the inverse Laplace transform of those functions. Okay, here you observe 1 upon s is there and 1 upon s square minus a square. These are two functions are there. You have to split them into two. Let phi 1 of s is equal to 1 upon s, and L inverse of phi 1 is, you have to find out the inverse of this function, that is 1 we know, and phi 2 is equal to 1 upon a square minus a square. What is the inverse of this? This is hyperbolic function, 1 upon a, this is sine hyperbolic a square's root, that is a t. Okay, once you done this step, you have to call f1 phi 1 inverse of phi 1 as a f1 t and inverse of phi 2 as a f2 t here. Okay, that's why let f1 t is equal to 1, f2 t is equal to 1 upon a sine a hyperbolic a t. Now by convolution theorem, write down the statement of this convolution theorem. L inverse of phi 1 into phi 2 is equal to inverse integration 0 to t f1 u f2 t minus u. That's why here L inverse of phi 1 into phi 2 means product of these two. Okay, what is the product of these two? That is our original function. You don't need to write this step. Okay, just for first example write down. Okay, this is equal to integration 0 to t f1 u means f1 t, replace t by u, but it is a constant function, that's why keep that as it is 1, no need to write 1. And f2 t minus u means whatever the t here in the f2 function, just replace t by this. Okay, here see, for finding out, there is no any rule for denoting phi 1 and phi 2, which function whatever, you can reverse this function also. Okay, but what is the next step, what we have to done with this phi 1 and phi 2? We are going to calculate the integration. Okay, if you observe this formula, what is the formula here? f1, both functions are there. Okay, first function is f1u. What is f1u means? Just replace t by u here wherever f1t is there. Okay, and if a second function is f2t minus u means what is the most difficult function or difficult process in this two function? In f2 only. Okay, f1u is not at all making difference in the function, because we have to just replace t by u here. Okay, and in f2 we have to replace t by t minus u. Whatever the function we are putting here, that function must be simple one. Okay, so that we can easily calculate the integration. Okay, that's why remember that whatever the function f1 we are getting, that must be that must be difficult, or whatever the function f2 we are getting, that must be simple one among the two. If you observe these two, 1 and 1 upon a sine hyperbolic 80, which function is the simple function? Obviously 1 is the simple function. Simple function is means that function which are having less amount, less number of multiplication or division. Okay, here only constant terms are there. Okay, that's why this is a simple term. Simple term we have to call it f2, because there is a difference in f2. Okay, remember that whatever the simple function we are getting here, call the simple function as f2 here. That's why we have to make difference here. Just call it as f phi2. Let phi2, this is obviously phi1, remaining the second one obviously phi1. Okay, you have to make this change after calculating inverse. Okay, after calculating the inverse only you will come to know which function is easy or simple. Okay, once you get it, just change the suffixes. This is 1, this is 2. That's why this is called f2 function and this is called f1 function. Okay, if you go by the earlier method, that is also okay, but integration becomes lengthy. Okay, that's why we are using here shortcut. Whatever the function we are getting, just identify the simple function, call it as f2. That means phi2. Okay, that's why we call it, we are making the change here. For f2 is equal to 1 and f1 is equal to sine hyperbolic. Now put these values here. What is f1u? This is t replaced by u only. That's why 1 upon a sine hyperbolic a t replaced by u. And what is f2 t minus u? Whatever the t here, you have to replace t minus u. But there is no any t here. That's why we are keeping as it is here. Okay, no need to write to 1 still. Okay, that's why just 1 upon a. Now we have to calculate this integration with respect to u, not t. Okay, whatever the function inside, the containing, which function containing u only, we have to take integration of that function only. Okay, now 1 upon is a constant, take outside. What is hyperbolic functions integration? Sine hyperbolic integration is cos hyperbolic. That's why sine hyperbolic au integration is cos hyperbolic au divided by obviously angles derivative we have to divide, that is a. Limits as it is 0 to t. 1 upon a square, a into a becomes a square. Now put the upper limit cos hyperbolic 80 minus cos hyperbolic 0. If you calculate on calculator, it comes 1. Okay, this is the most simplified answer for our inverse or example. Okay, now let us see the most second most example. You will get the idea of convolution theorem. Okay, now here we have to find out inverse of this function. This function, yes, numerator contain yes upon denominator contain 2 squares. We have to split this function into 2. Here only one yes is there. Split this function into 2 like this. 1 yes upon s square plus 4 and 1 upon s square plus 4, so that their multiplication is equal to our original example. Okay, now taking the inverse of this function, what we get? Inverse of this is cos 2t. Okay, and what is inverse of phi 2 here? Again 1 by 2, it is sine 2t. Now which function is easy here and which function is difficult? Both are trigonometry. That's why it doesn't matter whatever you call which function, whatever you call is phi 1 or phi 2. Okay, whenever there is same amount same type of functions, you don't need to think about phi 1 and phi 2. Just call whatever the function phi1 and second one the phi2. Okay, that's why this is keep this as it is. We take this is equal to f1t and this is equal to f2t. Okay, now write down the convolution theorem is this. Now put the values here everywhere. We get L inverse of phi1 into phi2 means multiplication of these two is our original example, which is equal to integration 0 to t f1u. f1u means just replace t by u here. We get cos 2u into f2t minus u means wherever t is there, just replace t minus u. We get half as it is, sine 2 as it is, replace t by t minus u. This is called f2t minus u. Okay, cos 2u and to take half outside of the integration because it is constant, and sine take 2 inside the angle, that is bracket 2t minus 2u. Okay, now we have to solve this integration with respect to u. Now we have to solve this integration using with respect to u. Okay, for that you have to use sine cos formula. Okay, what is sine? Take sine first and then cos second, because we have sine a cos b formula, that is half sine a plus b plus sine a minus b with respect to du. Make a square bracket here. Now take 1 by 2 outside of the integration. We get 1 by 4 into integration 0 to t sine 2u gets cancelled, 2t plus sine 2t minus this minus 2u becomes minus 4u. Integration with respect to u. Okay, now take this integration split into addition of trigonometry. We can take easily the integration with respect to u. See, here sine 2t is there. In first integration is first term. If you want to take integration of this sine 2t with respect to u, here in this expression it doesn't contain u term. That's why sine 2t becomes constant with respect to integration. Okay, that's why sine 2t take outside of the integration, and what it remains here 1. That's why one integration with respect to u is u. Okay, remember this step. Only wherever u is there with respect to u, that's why we have to take the integration of those function which contains u. This function contains u, that's why here we have to take integration of sine, that is minus cos. But in this expression, in this first term, there is no u term, that's why sine 2t take a constant from the integration, but 1 remains in the integration sign. That's why we have to take integration of 1. We know x, that is with respect to u, that is u. Okay, put the limit 0 to t plus, now sine integration is minus cos, angle is same, and divided by, we have to divide the angle derivative with respect to obviously u. What is the integration of angle with respect to u here is minus 4 only. This is constant, that's why its derivative is 0. That's why in the division we have to take just minus 4. Okay, integration with respect to limits are 0 to t. Now you have to put the limits sine 2t as it is. Upper limit you have to put u t in u. That's why t minus lower limit 0. You don't need to write 0. That's why answer for this only t plus minus comes plus. That's why 1 by 4 take outside. This is a constant, and you have to put t in u. Now 2t minus 4t becomes minus 2t. Okay, here in this step we take minus plus and 1 by 4 outside. Now put the limit 0 to t, 2t minus 4 to then minus 2t, and minus lower limit put u is equal to 0 here. We get cos 2t only. Okay, but you know cos of minus theta is plus cos theta. That's why cos 2t minus cos 2t, in next step it becomes 0. And answer will be t into, here our rest of the terms as it is, t into sine 2t divided by this 4. Okay, this is the second example. Okay, Here are some homeworks for you. This is the first homework. Okay, here you can split this. If you want to split this function into two, you can give this yes to this term or this term also. Okay, if you give this yes to this, you get cos here and here sine. If you put yes here in the numerator, you get cos here and here sine, but answer must be same. Answer comes same in the both method. Okay, this is the homework for convolution theorem. And this is other homework. This is a is a constant. You can take outside here a. In the first term only, you take this a into, you can write this as a into L inverse of s into s minus 1, and apply convolution theorem here because it is a constant. Okay. Now here put first function 1 by s and second first function must be easy. That's why 1 by s, take 1 by s as second function phi 2, and 1 upon s minus 1, that is exponential function, take it as a phi 1. Now here also 1 by s and 1 upon s square minus s square plus a square. This is 1, that's why take it 1 by s as second function, and 1 upon s square plus a square, which is cos sine, take it as a first function. Okay, whatever the easy function, you have to take second, remember. Now consider next example like that only. 1 upon s plus 2 into s square plus 1. You have to split this into 2. If you observe these two, this function is exponential inverse and this function is sine. Okay, that's why which is the easiest one, sine or exponential? Obviously exponential, because we can do easy calculations with exponential function than trigonometric function. That's why call it as f2. This function 1 upon s plus 2, take it as f2 or phi 2. Okay, that's why start with difficult one. Let phi 1 s is equal to 1 upon s square plus 1. Take inverse of phi 1, we get sine t. Call it as f1. Phi 1 means f1t. Now take for second function, that is a phi 2 yes, that is 1 upon s plus 2. Take inverse of this. 1 upon s plus 2 inverse is e raised to minus 2t, and call it as obviously f2. Phi 2 means f2 here. This is the first step. Okay, now consider convolution theorem. L inverse of phi 1 into phi 2 is equal to integration 0 to t f1 u into f2 t minus u du. That means inverse L inverse of, you don't need to write this product of these two. Okay, is equal to, now put the values. f1 u means here f1 t, replace t by u here, we get sine u, into f2 t minus u here. In f2 t, replace this t by t minus u. Okay, that's why it becomes e raised to minus 2 as it is, and instead of t you have to put t minus u du as it is. Okay, now we have to solve this example integration. Before that, you have to take constants outside. Therefore just simplify this. What is the simplification here in exponential? Just split this indices. What we get? E raised to minus 2t into e raised to minus minus plus 2u du. There are total three terms, and only first and third term contains u. Middle term e raised to minus 2t doesn't contain u. That's why it is a constant. Regarding this integration, take outside, and integration in the integration function remains e raised to 2u, take first, and sine u du. Okay, now this you have to solve by using well-known formula, that is e raised to, we know integration e raised to ax sine bx dx is equal to, this is the formula you have to mug up, e raised to ax upon a square plus b square. What is a? Exponential coefficient. And what is b? Angle coefficient. Formula is a sine bx minus b cos bx. Okay, now here a is equal to, in this example a is 2, exponential coefficient. What is b? Angle coefficient. Angle is no number is there, that's why it is 1. It is 1. Now put this value. I am using this formula here. We get L inverse of L, this LHS side is equal to e raised to minus 2t as it is, because it is outside the integration, and integration becomes e raised to ax, that is e raised to 2u, upon a square plus b square, that is 2 square plus 1, that is 4 plus 1, into bracket a sin bx, that is 2 sin u, minus b, that is 1, no need to write 1, cos u. Bracket complete, square bracket complete. Integration limits are 0 to t. Okay, now we have to take this constant outside, that is 4 plus 1 is 5. Take outside here and put the limits now at a time. You can do this step at a time. E raised to, first keep the bracket as it is until and unless you not done with the limits. Just don't remove the brackets, just keep them as it is. Here e raised to 2 instead of u, everywhere you have to, integration is with respect to u, that's why you have to put limit in u. E raised to 2t into bracket as it is, 2 as it is, sin u, that is sin t, minus cos t, bracket complete. Now lower limit 0 in u, e raised to 0 is 1, minus this is minus of lower limit, into bracket as it is, sin 0 we know 0, that's why just no need to write 0 here, minus sign as it is, and cos 0 we know 1. Okay, bracket complete and complete integration complete. This is the answer. Now simplify this as it is in the bracket, e raised to 2t, 2 sin t minus cos t, minus minus plus 1. Okay, now take this e raised to minus 2t upon 5 inside, we get most simplified answer is 2 sin t minus cos t plus e raised to minus 2t whole divided by 5. Okay, this is the one more example of convolution theorem. Now these are some homeworks. Okay, this is the homework only, that is s upon s minus 1 into other bracket s square plus 4. Okay, if you want to split this example into two function, where we have to put this s for which function, obviously here, not here. Okay, because if you put here, you have to you cannot inverse find out the inverse easily here, but if you put yes here, it is a cos, that's why observe the things, then only you can split the function logically. That's why take first, and this is cos and it is e raised to exponential, that's why exponential is easy one, that's why we have to call it as f2. That means here take phi 1 is equal to s upon s square plus 4, and phi 2 is equal to easy one, that is 1 upon s minus 1. Okay, this is the hint for this example. Now consider next. Here we are directly solving this.